So I'm going to show you how to set up a joint speed check in DCS. So we'll open up our pendant. And the main purpose of a joint speed check is to monitor the speed of an individual axis or joint inside of the robot. So to get to the menu, we're going to go to Menu, 0next, System, and then DCS. I put my display back to single wide. So for a joint speed check, it's similar to a joint position check in terms of how the menu looks, but we can set up one individual axis. So make sure we give it a comment, tell it what we're doing with it. We're going to go ahead and enable that, and then we can identify the direction of that axis. So if we only want to monitor it in a specific direction, plus or minus, then we can select that so it's only going to monitor in the positive or towards the positive or towards the negative. Most of the time we use all. And group, this is going to be what group or motion group is it attached to. So right now in my work cell here, I've only got one robot. If I had like a turntable or a rotary fixture that was attached to the robot, chances are it's either going to be as an additional axis, so like axis 7 or 8. Sometimes we do set that up on multi-group motion, so it would be under group 2 for that extended axis. So I'm going to leave it at group 1 because I don't have any other groups. And then for my axis, I'm going to go ahead and I can choose any axis that is available that's being used on that robot. So I'm going to go ahead and set it up on 5. It's just easier to see just what we're doing. So speed in degrees per second. Most of the time when I set up joint speed checks, usually I'm using it as an override for my speed limit. So up here, we can dictate and change the speed up here. But degrees per second. So think of it as in, like it says, degrees per second. How many degrees is it going to be able to move? And I'm just going to go ahead and limit this down. If your speed check is, you just notice that it's moving too slow or it's moving too fast, then change this value here. And then our stop type, we're going to go ahead and keep it at stop category 0. So this means that it's going to be an immediate stop on the robot. Stop category 1 is going to be more of like a controlled stop. So it's going to kind of come to a coast stop. It's not as violent as the category 0. And then a not stop is just strictly for monitoring that axis to see what that speed is if you would need to do that. This is strictly just for data. So not stop meaning it's not going to stop if it goes outside of that limit. So we'll leave it at stop category 0. And for right now, we're going to leave this speed control disabled, and our override limit we're going to leave alone too. The last couple things here, so disabling input, if I wanted to temporarily disable this speed check, I can do that using a variety of DCS or safe signals to be able to control that. I'm going to leave it alone. I don't need a disabler. And then permissible distance, this can be kind of dangerous because if your axis is moving past a certain point or past a certain speed, and you're underneath of your speed setting, it's might be able to go outside of that axis range based off of how many degrees it goes over. So I usually leave this set to 0, and then our delay time, it's going to delay the time that your joint speed check in DCS is actually triggered. So I'm going to go ahead and apply this so we can see it. So apply, and then we need to cycle our power. So main places where we set up a joint speed check is going to be on your axis 5 and 6 because we're usually concerned about the end of arm tool maybe moving too fast, especially if you're handling a heavier product, or maybe you're doing stuff with liquids or something like that where you don't want that end of arm tool just kind of like blinging around, just as fast as it can go. You want to be a little bit more cautious about what you're moving. It's also nice to be able to limit down those axes so in the event that your robot would maybe come in with a collision because you programmed or somebody programmed it to go past that point, it's going to protect your end of arm tooling. So in my previous video, we talked about joint position checks where we can actually limit that down to protect it positional wise as well. So now that this is applied, we should be able to jog our robot. And so right now, since I'm moving at 100% speed, I'm going to get this joint speed limit alarm saying axis 1, JSC 1, group 1, axis 5. So if I would reset this, and we're going to limit it down to like maybe 5%. Now my axis 5, oh, put it in joint here. Now my axis 5 is actually able to move. So if I bump this up to maybe 10%, we can see where we can get it to limit out. So 10% it's just fine. Go up to maybe 20. So this is that representation of 5 degrees per second. All axes are going to move at a different degree per second speed, just due to the mechanical setup of the robot. So you would have to play around with this to get your desired speed. Next thing I'm going to show you in that joint speed check is how I like to use it, and that is to limit my overall speed of my robot. So we don't have somebody walking up next to the robot and they see on the pendant, oh, it's right now that robot's only limited to 20% of its total speed. We don't just bump up our speed and produce more parts or whatever that may be. So we can leave our limit alone because it's not really going to affect anything here. Speed control, we're going to go ahead and enable this, and we're going to go to override. Now your override limit of percentage is going to be your overall speed percentage. So if I wanted to limit it to, let's say, 20%, come in and make sure that actually took. Okay, so yeah, it's saves. And now when I go to bump up my speed on pendant, it's not going to let me do that. It'll flicker for a minute, but it's not going to go over that 20%. So now my robot's locked down to 20% of its actual speed capabilities.